Problem-solving techniques. There's a couple of interesting things to remember when problem-solving in the fluids chapter. They are often overlooked, making problems more difficult to solve. The first, the formula for the buoyancy force is this: F sub B, the density of the fluid, gravitational acceleration, times the volume of the submerged object, or the submerged portion of an object. The subscripts are often forgotten. You cannot do that in this chapter. The density that is used in the equation is the density of the fluid. It even says that. That's why, again, it's important to remember the subscript, not the density of the object. The volume that is used is only the portion of the object's volume that is submerged in the fluid. It could be the full volume, but only if the object is fully submerged or under the fluid. When the object is floating, right, part of the object is above the fluid, part is submerged, the buoyant force is equal to the weight of the object, okay, where weight equals mg. This means that the weight of the fluid displaced is equal to the weight of the object. So what we have is the mass of the fluid displaced times g is equal to the mass of the object times g, the mass of the whole object. The weight of these two are the same because the object is less dense than the fluid. Now we have the object on the bottom of, well, let's call it a beaker, and let's call it water. The buoyant force is less than the weight of the object. The object is resting on the bottom of the glass, so what other force do we have? Normal force, a contact force. The weight of the displaced water is not equal to the weight of the object. Okay. However, the object is fully submerged, so the object's volume is the same as the volume of the displaced fluid. So in the first case that we did on the previous slide, the mass of the object is equal to the mass of the displaced fluid. This time, the volume of the object is equal to the volume of the fluid displaced.